Bismillah ar-Rahman ar-Rahim. We'll start now section 5.5, which is about how to solve non-homogeneous equations. Actually, there are two methods. Undetermined coefficients is one of them, and the other one is variation parameters. So let us talk about how to deal with non-homogeneous equations. First, I will start with the superposition principle for non-homogeneous equation, which actually in the book was discussed in some questions in section 5.2. But I put it here so that it's related to non-homogeneous equations. What's the idea there? It says if you have a differential equation, you have an operator applying on function y, and yeah, so my operator is L is what? Is d square plus PD plus Q. That will be my L, my operator. Okay. Now if I apply it in a function, and now it's easy to writing it this way instead of writing the equation every time. So you have, assume I have, if I apply operator on a function on y1, I'm getting a function f of x. That will be my right-hand side. If I apply the same operator, which is the same differential equation, in another function y2, I'm getting gx. Getting gx. The superposition principle saying what? Now, if we apply L in y1 plus y2, the right-hand side f of x plus g of x. In other words, if the right-hand side is f, I'm getting y1, and if the right-hand side is g, I'm getting y2, then if the right-hand side is f plus g, then I should get as a solution y1 plus y2. Not only that, it's more than that. If you have L, you apply it in C1 y1 plus C2 y2, a linear combination of these. The right-hand side will be what? C1 f of x plus C2 g of x. So if I know the solution for this equation, where the right-hand side is f, and they have the same L, and the right-hand side is g, then I get another solution y2. Now, if he gave me an equation where the right-hand side is the sum of these two, not only the sum, also any linear combination of these two. So what will be the solution of this new equation? It will be the linear combination of these two solutions, y1 and y2. Okay, and this is what this is what he was saying here, and this is the general one. If yp1 is a particular solution of this equation, Ly equal g1, and they have yp2 is a particular solution of this equation. Then what will happen to this equation? Ly equals C1 G1 plus C2 G2. That will be my particular solution. The linear combination of these two solutions. Let me first show this 25, question 25. He said, show that if you have L of y is y double prime plus p y prime plus qy. And I have y1 is a solution of f. So I have, it means if I apply L in y1, I'm getting what? I have y1 double prime plus p y1 prime plus q y1, I'm getting f. If I apply L in y2, so I have y2 double prime plus b y2 prime plus q y2, I'm getting g. He said, show that if I apply L in y, which is the sum of these two solutions, y1 and y2, I should get the right-hand side f plus g. So I need to show L of y1 plus y2, L of y1 plus y2 should give me f of x plus g of x. Okay. How to show that? I will go with the right-hand side, left-hand side, sorry, which is L y1 plus y2. Means I need to apply the operator, which is this one, on y1 plus y2. That means it is y1 plus y2 double prime. So I consider y1 plus y2 as y. Huh? So plus p y1 plus y2 plus q y1 plus y2. Now let me do the calculations. I have y1 double prime plus y2 double prime plus p y1 plus p y2 plus q y1 plus q y2. So they have prime here. So I have prime. Okay. So that now I combine the things with y1, that y double prime plus b y1 prime plus q y1 plus y2 double prime plus p y2 prime plus q y2. This is what, according to this is f of x. This is what, according to this is g of x, which is the right-hand side. Okay. By the way, for general L, I want L to be linear operator. Yeah. Okay. Now let me apply it to this question. Okay, which is question 26 in section 5.2. Okay. Now he said find by inspection, just by looking, particular solution of these two equations. So let me do A. I need to find by inspection a solution of this equation. It's very clear to me that if I have a constant, if I apply a constant, then y double prime will be what? Will be 0. If y equals c, then what will happen? I have y double prime will be 0, y prime will be 0. So y double prime will be 0. So I have what? So I'm getting substitute into the equation. Let me call it 1. I have what? 0 plus 3c equal 12. So c equal 4. So that will be my solution. I can check it easily. If I have, so my solution, y equal 4. If I substitute y equal 4, y double prime will be 0. 3 times 4 is 12. So it's a solution. So this will be my solution. That's what he means by inspection. Just if you look at it, you can see it easily. Now P, y double prime plus 3y equal 15x. So for sure I need y to be a function of x, because y double prime will make it 0. It will be constant times f, so I need 5x actually. Check. Y equal 5x is a solution. Yeah, because y prime will be 5 and y double prime is equal to 0. So now I have 0 plus 3 times 5x is 15x. So this is my solution. A particular solution. Okay. Now let me do this is A. Let me do part B. Let me try to squeeze it here. I have what? This is, I can rewrite it as Ly. I can write this Ly equal 12. And I have Ly, the same L, equal 15x. Okay. So for YP1, which is 4, is a solution of Ly equal 12. And YP2, which is what 5x is a solution of Ly equal 15x. Notice I have the same L, the same differential equation, the same, left-hand side. Now, the question is, we need to find a particular solution of this equation, which is what? Now, solve Ly equal 15x plus 12. Yeah. Let me call this f of x, the 12. And let me call this g of x. So this is what? Ly of g of x plus f of x. So according to this superposition principle, if I know a solution for Ly equal g1 or g of x, or let me say it here, Ly1 equal f of x, Ly2 equal g of x. So I have y1 is for f, y2 for g. What will be for f plus g? Y1 plus y2. So right away, my solution is yp1 plus yp2, since I have g plus f. Or to make it, I have f g yb2 plus y. That will not make a difference, but just for to make it more clear. Okay, so I have 15x plus 4. That will be my solution. Not 15, 5x, sorry. Y2 is 5x, so that will be 5x plus 4. Okay, let me do another problem. Okay. We said first, verify that this is the solution of this equation. And this one is the solution of this equation, respectively. Okay. So let me do A. How to show it's a solution? Just I need to check left-hand side. So I need y prime and y. I need y prime and y double prime. So let me find y prime. 6e to x. What is yb double prime? yp1 double prime. That will be 12e to x. So I say now left-hand side, which is yp1 double prime minus 6 yp1 prime plus 5 yp1. That will be what? That will be 12 e to x minus 6 times 6 minus 36 e to x plus 5 times 3 plus 15 e to x. That will be what? 27 minus 36 e to x, and that will be minus 9 e to x, which is the right-hand side. So this is correct. Now I need to show for yp2. What is yp2? It's x squared plus 3x. So what is yp2 prime? 2x plus 3. What is yp2 double prime? That would be 2. Now check left-hand side. yp2 double prime minus 6 yp2 prime plus 5 yp2 equal what? That is 2 minus 6, 2x plus 3. Okay. Plus 5 x squared plus 3x. And that's equal to what? Do the calculation. 2 minus 12x minus 18 plus 5x squared plus 15x, which is equal to what? 5x squared. That is it. 15 minus 12x, that is plus 3x. 2 minus 18, that's minus 16, which is the right-hand side. So this is correct. Now I proved there are solutions. Okay, now let me do part B. Yeah, what I have y double prime minus 6y prime plus 5y. Let me call it ly. That will be minus 9 e to x solution. IP1 is 3, huh? 3e to x, yes. And I have ly equal same L, huh? 5x squared plus 3x minus 16. Solution yip2 will be x squared plus 3x. Okay. Now I'm doing B, huh? I'm doing B. First one in B. Solve this. Ly, which is what? Y double prime. Same one, just to equals what? What is what's the right hand side? 5x squared plus 3x minus 16 minus 9. Yes, minus 9 e to x. Let me call this f of x. Let me call this g of x. What is this? This is g of x. And what is this? This is f of x. So this right hand side, g of x plus f of x. So it will be my solution. Since I know yp1 is a solution where I have f of x, and yp2 is a solution where I have g of x in the right hand side. So the solution for this equation will be yp2 plus yp1. And that is what? X squared plus 3x plus 3e to x. Yes. Now, the second one, I need to solve ly equal the same, notice the same differential equation, but the right-hand side is different. Minus 10x squared minus 6x plus 32 plus e to x. Now, it is not f of x plus g of x, but it's like a multiple of it. So if you notice, this one is what? If I take minus 2 common factor, I have 5x squared plus 3x minus 16. And this one, if I take minus 1 over 9 common factor, I have minus 9 e to x. Why I took minus 1 over 9? Because I want this one to be similar to this one. So this one is what? Is minus 2 g of x minus 1 over 9 f of x. So it will be my solution to this equation. it will be the same constant like what we did here. We said if I have C1 F1 f of f plus C2 g of x, I have C1 y1 plus C2 y2 is my solution. So that will be minus 2. G is for yp2, correct? Yeah. So minus 2 yp2 minus 1/9 yp1. And now just do the calculation. It will be minus 2 x squared plus 3x minus 1/9 3e to x. And that give me what? Minus 2x squared minus 6x minus 1/3 e to x. Okay. Just to be sure. Yes. Minus 2x squared minus 6x minus 1/3 e to the power 2x. Good. This is just, as I said, this is just a question in 5.2, but since related to non-homogeneous, I brought it here. And this is the superposition principle for non-homogeneous equations. Okay. I think we did a good number of questions. Yeah, I think we explained it good. Now we'll go back to how to solve non-homogeneous equations. This is the non-homogeneous equation. This is the way we wrote the non-homogeneous equation with constant coefficient. These are constant coefficients. Yeah, it's in general. We can make it in general. But what I will do to solve this non-homogeneous, first I need to solve the homogeneous. First we solve the homogeneous. This is the homogeneous, associated homogeneous, associated homogeneous. And we solve it and we get to YC, which is called complementary function. And also I get a particular solution of the homogeneous, of the non-homogeneous. Okay, the particular solution of, call it 1, of 1. Then what will be my general solution of 1? It will be YC plus YP. So our main task in this section is to find YP. YC, we did it before, in section 5.3, to find YP, especially if we have constant coefficients. So the idea is what? First, I write the associated homogeneous equation, solve it, find the YC, find the complementary function, the general solution for this homogeneous, and try to find a particular solution of the non-homogeneous. Then the general solution of the non-homogeneous is YC plus YP. Let me make it clear. First, find YC for the homogeneous. YC was the general solution for homogeneous. 2, find YP for non-homogeneous. Okay. General solution for non-homogeneous is Y equal YC plus YP. Okay. We have two methods to do that. The first method called the undetermined coefficients. Undetermined coefficients. And the idea is to make, the idea of this method is how we can make an intelligent guess for the form of YP. And then we'll try to find that YP. Okay. So if I have this equation, by the way, this undetermined coefficient, it will not work for any right-hand side, for any f. No, it will work only if f of x is a linear combination of finite products of functions of the following types: polynomials in x, exponential functions, which is e to the power ax, or cosine bx or sine bx. These are the, if I have a product of these functions, polynomials exponential function in this form, e to the power ax, cosine and sine, then I can do undetermined coefficients. And the main things in this undetermined coefficients is how to guess yp. How to guess yp. Let me do it by an example. This one, if I want to solve it, what I will do, as we said, so first, solve the homogeneous. Okay, this is we know how to do it. Let me do it quickly. Auxiliary equation, r squared minus 5r plus 4. That would be r minus 4, r minus 1 equals 0. So I have r equal 1 or r equal 4. So it will be my general solution, which we'll call it yc, c1 e to the power x plus c2 e to the power x. Now find yc. What I need to solve the differential equation? We did yc, we did this first step. I need what? Yp. Okay. Second, find Yp for the non-homogeneous equation. The idea of this method is to try to guess Yp in an intelligent way. Okay. If the right-hand side is 4x plus 2, and I need, for sure, I need y double prime, y prime, and y. Okay. If I make y, let's make it, yeah, to make it clear. If I make y function of e to the power 2x, for example, will that give me 4x plus 2? No. If I substitute it, I have y prime, y double prime. For sure, I will not get 4x plus 2. If I have cosine or sine, also that will not work, will give me sine and cosine. So my guess will be what? Since I have 4x plus 2, my guess will be ax plus b. That will be my guess. Since if I have y prime will be what? A, y double prime will be 0. So it means I need to multiply, this is by 1, this is by minus 5, this is by 4. So my left hand side, so my guess for yp is yp equal ax plus b. So substitute it here. Now substitute. I'm doing it in details. Yp double prime minus 5 yp prime plus 4 yp. That should be equal 4x plus 2. That will be what? 0 minus 5a plus 4ax plus 4b. Notice this side, it has what? A constant times x and a constant plus constant. So it will work fine with this right-hand side, 4x plus 2. Because with that, my guess will be a good guess. Now, just I equate the coefficients. I can rewrite this one as 4ax plus 4b minus 5a, that equal 4x plus 2. So if you look at the coefficient of x, I compare this with this. 4a equal 4. This is my first equation. If you compare the constant, you compare this with this, that will be 4b minus 5a. That's equal to 2. So I have two equations, two unknowns. Solve it. I get what? A equal 1 from here. Plug it here. I have 4b minus 5 equal 2. So 4b will be 7. So b equals 7 over 4. Good. So what is my solution? Yp. So it will be my solution, which is Yp. Ax, so it will be x plus 7 or 4. It will be x plus. So it will be general, my general solution for 1. Let me call this one. Oops. For 1. Y will be yc plus yp. And what is yc? This is my yc. For x. And what is my yp? This is my yp. And that will be my solution. Which is clear. Now, if I want to do a particular solution for this equation, what will be my guess? Let me first solve the homogeneous. He doesn't want me to do, but I will do it. Solve this. I'll tell you later why I'll do it. I have r squared minus 5r plus 4. And that will be r minus 4, r minus 1 equals 0. Correct? Yeah. So I have r equal 1 or r equal 4. So I have general solution for the homogeneous. C1 e to the power x plus C2 e to the power 4x. By the way, it's the same equation. Yeah, same left-hand side. Okay. Now, for YP, what is my guess? Shall I say YB? Let me try it. AX squared. Will that do it? Let me check. YP prime will be what? 2AX. YP double prime equal 2A. Plug it into the equation. I have 2A minus 10AX plus 4AX squared equal 8x squared. Yeah, I can think of this, which is not correct, but I can think of this as 8x squared plus 0x plus 0 times 1. So if I do the conversion of the coefficient, I have 4a equal 8, so a equal 2, but I have minus 10a equal 0, which implies a equals 0. So there's a problem here. Cannot be. So my guess is not correct. Okay. What will be my guess? Yeah. If you notice here, we said if f of x is a polynomial of degree m, then the particular solution has this form. I start with a0 until I reach the degree m. So here I have x squared. So my guess will be what? Yp. I will start from the constant until I reach x squared plus bx plus cx squared. That will do it. Let me check yp prime. Let me see what will happen. That give me b plus 2cx yp double prime. That give me what? 2c. Now substitute this here, so I need what? 1 minus 5, 4. So what is my guess? Yp a plus bx plus cx squared. If I have cube, I'll write the dx cube and so on. So substitute in 1. To get what? I have 2c, 5 times this, minus 5b, minus 10cx, plus 4a, plus 4bx, plus 4cx squared. That should equal 8x squared. Now you compare the coefficient, like what we did before. So you have x squared. What's the coefficient? I have here 4c, and that should equal to 8. So c equal to, very clear. Now what's the coefficient of x? By the way, I can think of this as plus 0x plus 0 times 1. Okay, so what's the coefficient of x? I have minus 10c and 4b. So I have 4b minus 10c. And that should equal to what? To 0. I know c is 2. So I have minus 20. So that means in 4b minus 20 equals 0. So b equal what? 20 over 4, which is 5. So b equal 5. Now what will be the constant? The constant I have 2c minus 5b plus 4a. So I have 4a minus 5b plus 2c, and that should equal to what? To 0. Okay. I know c is 2. I know b is 5. So I have what? 4a minus 25 plus 4 equal to 0. So I have 4a equal 21. So a equal 21 over 4. So that means what will be yp? Yp, it's what? We said it's a is 21 over 4. B times x, what is b? 5 plus 5x plus c, which is 2x squared, which is this one. If you want the general solution for 1, that will be what? Y equal yc plus yb, and that is this. Did not ask for it, but this is just for the information. Okay. Now, if the right-hand side is a function, a constant times e to the power 3x, e to the power ax, what will be my guess? If I put a polynomial, it will not work. So my guess will be e to the power, the same a. It depends if there is x, then I do the same thing. I have the constant until I reach the power. So let me, as usual, we solve the homogeneous. That means I have r squared minus 4 equals 0. So r equal plus or minus 2. So yc will be c1 eos minus 2x. Okay. Now for yp, what is my guess? For sure, I will write yp a e to x. And yp prime will be what? 2a e to x. Yp double prime will be 4a e to x. And it's not like this is by 1, this is by 0, this is by minus 4. This is called it 1. So my guess, yp a e to x, substitute in 1 to get what? 4a e to x minus, is it? That will be a e to x, a 3x. What is this? This is 3. Sorry, this is 3. Okay. That will be 3ax. That will be 9. Yeah. I need this. The guess is about this, not about this. Okay, so it's about this one. A e3. A to the power 3x. Sorry. So that give me 9a e3x minus 4a e3x. That should equal to what? 2e3x. In other words, I have 5a e3x equal to e3x. So for sure I have 5a is equal to 2. So a equal 2 over 5, which means my yp is what? I know a. So it's 2 over 5 e to the power 3x. And my general solution for 1 is what? Y equal yc plus yp, which is c1 e minus 2x plus c2 e to x plus 2 over 5 e3x. Okay, now if the right-hand side has cosine or sine, it says if you have cosine or sine in the right-hand side, I need both cosine and sine, because when you do the derivative, you have either sine or cosine. If you have cosine, first derivative gives me minus sine, second derivative gives me minus cosine. So I need sine and cosine. Okay, let me do the same thing. First, solve the homogeneous. So what is the auxiliary equation? I have 3r squared plus r minus 2. And that is what? That is 3r minus 2 and r plus 1. Is it? Minus 2r plus 3r is r. That's good. So I have r equal minus 1 or r equal 2 over 3. So what is general solution? Yc. So what is Yc? C1 is minus x plus C2 e2 over 3x. Okay. Now for Yp, what is my guess? I will make Yp a cosine x. I need sine and cosine. So what is Yp prime? It's minus a sine x plus b cosine x. Yp double prime will be minus a cosine x minus b sine x. And I need to, this is multiplied by 3, this is 1, this is minus 2. Okay, so my guess, Yp equal a cosine x plus b sine x. Substitute in 1, and this is 1. What I will get? Minus 3a cosine x minus 3b sine x Okay, minus a sine x plus b cosine x minus 2a cosine x minus 2b sine x. And that should equal to 2 cosine x plus 0 sine x. Okay. So what is the coefficient of cosine x? From this side, I have minus 3a plus b minus 2a. So I have b, or let me say minus 5a plus b, and that should equal to 2. I have minus 3a minus 2a. That gives me minus 5a plus b. Now, what is the coefficient for sine? I have minus 3b minus a minus 2b. So I have minus a minus 5b. Minus a minus 5b, and that should equal to 0. Okay. So I need to solve these two equations. One way to do it, I can multiply this equation by minus 5. So I have 5a, that will make it easier. So I have minus 5a plus b equal 2. And I have 5a plus 25b equal to 0. Add them. I have 26b equals 2. So b will be 1 over 13. Plug it in this one. I'm getting what? Minus a minus 5 over 13 equal to 0. So a equal minus 5 over 13. So what is my yp? I have a, and I have b. And I have the function. What is the function? Yeah, this is my function. So a is minus 5 over 13 cosine x plus 1 over 13 sine x. What is my general solution? For 1, y equal yc plus yp. And that is this is why my yp, which is the same as this. Okay. Okay. Now, is that mainly the undetermined coefficient? No. We need to be careful. Look at this equation. Y double prime plus minus 4y equals 3e to x. I want to solve this. Y double prime minus 4y equals 3e to x. I know how to solve the homogeneous. YC will be, I think we did it before, y double prime minus 4y. Yeah, it is C1E2. So my guess, what is my guess for YP? Is it A e to x? Let me check. What will be YP prime? It will be 2a e to x. YP double prime, that will be 4a e to x. So you multiply this is by 1, this is by 0 minus 4. So substitute, you have what? 4a e to x minus 4a e to x equal 3e to x. I have 0 e to x equal 3e to x. What is this? There's a problem here. So I cannot do it this way. Yeah. What do you notice? I notice, because of that it's good to find yc. I notice the yc contains e to the power 2x, contains the same one as that one. Okay, so this is what we call the case of duplication. Okay. So assume it's 3. Yeah. This happens when f of x satisfies homogeneous differential equation of which a root of the characteristic equation is also a root of the characteristic equation corresponding to the original differential equation. That will make a problem. That we call it the case of duplication. Case of duplication. Now I'll explain a method where we can deal with this case and also with the original case. The book is doing it in a different way, but let me do it in I think in an easy way. What is the method? To do the method, you remember if I gave you a function, if we gave you like 3e to the power 2x, we say this is a solution. Here's a solution. Find the differential equation. How to do that? We'll try to find the root. What will be the root? Which will bring this? For sure, the root is 2. That's what I need. So what will be my method? My method will be like this. First, find yc. Find yc, the method. Let me write the method. Find. Yeah, let me try to make it in steps. Find yc. Not mainly yc, I want the roots of the auxiliary equation for yc. For the homogeneous. That's what they want. Second, find, yeah, I don't know how to state it, but I need to find the root, find the roots where f of x satisfy a homogeneous differential equation with constant coefficients. Find the roots where f of x satisfy a homogeneous differential equation with constant coefficients. What's my third step? Assume I have here list of roots. Let me call it R1, R2, up to who cares? Rm. And I have now roots from here. T1, T2, up to Tn. Combine all roots. In one list. You know what? Let me do that. write the method in here better. Yeah. So the method just Ly equal f of x until now. First, find yc for Ly equal 0. By the way, Ly should be linear operator. L is a linear operator. With constant coefficient. I need that. It's not for any linear operator. Okay, with constant. So first I find yc for Ly equals 0. And find the roots of the auxiliary equation. Call them R1, R2, up to Rm. Assume I have m roots. My first step. Then find the roots. Find the roots where f of x satisfy a homogeneous differential equation with constant coefficient. Let me call those roots T1, T2, up to Tn. Then combine all roots in one list. This is the method. So I have now R1, R2, up to Rm, and T1, T2, Tn. If you have the roots, we can construct a solution. Construct a solution. Usually we call it yp hat. Which comes from where? Which comes from all of these roots. If I have, yeah, which is usually we do it. It depends if it is real or not real or distinct or repeated. We combine, we get yp hat. My last step, cancel yc. The remaining is my guess for yp. Which is clear. Let me do it by an example that will explain it. And that when I will do it, if I have a duplication, if the roots coming from here and the roots coming from here, I have a duplication. Okay. Like in this case, what will be the root coming from here? Is 2. Yeah. Okay. This is I wrote it in different ways. Okay. And what are the roots? Now let me do it this way. Y double prime minus 4y equals 3 e to x. What are the roots coming from here? Minus 2 and 2. What are the roots coming from here? 1. This is my first step. Find those roots and find those roots. Okay. This is 1. This is 2. 3. Make the new list. That new list is what I have. Minus 2, 2, 2. This is my third step. Combine all the roots in one list. My first step, construct a solution. For what is yp hat? I combine those. C1, e minus 2x plus C2, e to x. Since I have repeated, plus C3, x, e to x. Is that my YP? No, I call it YP hat. What is my YP? First, last step. What I will do, this is YC, cancel YC. Cancel this, I cancel this. So it will be my YP, AX, E to X. That will be my guess. And then I need to do the calculation to find the A. Okay. I wish it's clear. Let me do one example. Let me do this example. Yeah. Okay, let me do this example in details. Now I have my YP is AX, E to X. What, by the way, what's the equation? Y double prime minus 4y equal 3e to x. Okay, so it is yp prime, and you have product of two functions, a e to x plus 2a x e to x. You need to be careful with the calculation. Yp double prime, I have what? 2a e to x plus 2a e to x plus 4a x e to x. I need to multiply this is by 1, this is by 0, this is by minus 4. So substituting 1, my guess is yp equal a x e to x. Substituting 1 equal this one. I have what? Let me do it here. 2a e to x, actually 4a e to x plus 4a x e to x minus 4a x e to x. That should equal 3 e to x. I do a mistake. This is ax, so it will be a e to x plus 2a x e to x. 2a plus 2a plus 4a x e to x. Yeah. This is by 1, this is by minus 4. Half. It's half. I'm getting that half. 3a to x. ax, a to x plus derivative of this 2a x e to x. What's the derivative of this? Now 2a e to x plus 4a x e to x. I didn't see a mistake here. Okay. So now this is cancelled. So I'm getting 4a equal 3. So it means a is 3 over 4. So my yp is 3 over 4 x e to x. Let me check. Yp prime would be what? 3 over 4 e to x plus 6 over 4, which is 3 over 2 x e to x. Yp double prime would be what? 3 over 2. What's it? 6/4, which is 3/2, e to x plus 3/2 e to x plus 3x e to x. Now multiply this is by 1, this is by 0 minus 4. Multiply this is by 1, I'm getting 3/2 e to the power 2x. Oh, no, I'm getting 3. This is 3. This is actually 3 e to x plus 3x e to x. So that'll give me 3. Substitute in this one. I have 3 e to x plus substitute in 1. Substitute in 1. I have to check. I'm getting what? 3 e to x plus 3x e to x minus 3x e to x. That gives me 3 e to x, which is the right hand side. So this is correct. So my answer is correct. So this is my YP is correct. Actually, it seems to be there is a mistake here. This is not. This is 3/4. I'm doing it with e to x. Yeah, that should be 3/4. Okay, no problem. The idea should be clear. So this is my A. So YP will be 3/4 x e to x, and my general solution y equal yc plus yp.